Hello family, it's Kuseko again. We are going for heat form 5s. So talk about heat actually, we're just going to have the three parts. The first part is what we call the thermometry. What is thermometry? Is just the science to measure the temperatures. Talking about the second part is what we call the heat transfer. Talking about to the next point. There are three mechanisms here we are just going to discuss. We're just going to discuss about actually the conduction, the radiation, and convection. So the third part that we just got to discuss is about the thermodynamics. So let's go directly to heat. If it's your first part, it's your first time to join my channel, make sure you subscribe for more videos. Okay, so we are just going for heat. The topic is heat, form 5s. So heat, we are just going to discuss about the three subtopics. The objectives. We are going to discuss about one, we're just going to discuss about the thermometry. What is thermometry? The science of measurement of temperature. Thermometry. So you need to know how to measure the temperature and the types. The other thing that we are just going to discuss here is actually about what we call, number 2, is about what we call heat transfer. Heat transfer. So here we're just going to discuss about the three methods that we use to transfer heat. The other thing is about the third thing. Actually, the third is about what we call the thermodynamics. Thermodynamics. Okay, so talking about the thermometry is what I need to start with. And let's go on for the what we call the first thing is about the thermometry. So talking about thermometry, what is thermometry actually? Thermometry is the science for the measurement of temperature. So before we discuss thermometry actually in the science of measurement of temperature, we're just going to discuss the two concepts. Very important. The first thing, you just go to discuss about the terms that are used in heat. These terms are very important to give you the concept on how we measure the temperature, how the heat is being transferred, what is thermodynamics. So the general concept about heat, we're just going to discuss in thermometry, the definition of terms. And the other thing that we're just going to discuss in thermometry is about the types of thermometers. You need to know the types, their advantage, their disadvantage, why to use this, why not to use this, how is the mechanism, why is the mechanism. Because in competence, you need to know what, you need to know how, and you need to know why. For what and for why, for how. Okay, so let's go on for the thermometry. Talking about the thermometry, I'm just going to discuss about the types actually for the thermometer, and I'm going to discuss about what we call the terms. Very important terms used. So we'll discuss about terms and concepts here about heat. So before I just go on, let me say what is heat. The topic is heat. What is heat? Talking about the heat, this is just the average, this is just the energy that is being transferred from one point to another due to the differences in temperature. So whenever there is 2 points which have the 2 different temperatures, the energy that can be transmitted from one point to the other due to the difference in temperature is what we call the heat. So talking about heat, it's just the energy being transferred due to difference in temperature. So talking about the heat, actually, the introduction, let me talk about heat. Terms now. So terms here is about heat. What is heat? The first term. What is heat? Is the energy due to difference that can be transferred from one point to another due to difference in temperature. Kwa kukiwa na utofauti wote wa joto, manake heat is being transferred. It's actually measured in terms of joules. And you have seen in O level, you have studied about heat. Actually, heat is the energy due to difference in temperature. So if you have your mass, you must have a change in temperature. So they are directly proportional to temperature actually. Even if you are dealing with those latent heats for specific temperatures. For example, latent heat of vaporization, you just have to have the mass and latent heat of vaporization. If you are dealing with latent heat of fusion, you just have to have the mass and latent heat of fusion. So those about heat. So we have heat as the image, but we have the temperature as the physical signification that there is heat. So to observe that here at this point there is heat, we must observe its temperature. So heat is the image, while the temperature is what we call the degree of hotness or coldness. Temperature is the one identifying the amount of heat, amount of this image present at that point. So talking about the other term, the second term is what we call the temperature. Also, what's the temperature? This is just the degree of hotness or coldness of the body. So this is just the degree coldness or hotness of the body. That's what we call the temperature. And the temperature is just being measured in what we call a thermometer. Thermometer. So talking about actually, this is measured by thermometer. Yeah, thermometer. And this is what we are just going to discuss here in thermometry. What is thermometry? The third term, thermometry. What is thermometry? So I just love here about that topic. And let's go on. Let's move on. So talk about actually about what we say. So talk about the thermometry. The third term is what we call the thermometry. So talk about the thermometry is the science of measurement. Is the science of measurement. Measurement of temperature. How the temperature is being measured is what we call the thermometry. So here in the thermometry, I've just said we just discussed about the terms. In our terms are those which we have just started. So we are just going for the number 4 is what we call the other term that is just being used in order to say that you understand about this is about what we call the scales, the temperature scales, scales. Yeah, you need to know about the scales. So talk about the scales actually. Temperature scale. This is the mode that is being chosen as the standard for measurement of temperatures. So Scientific Society chooses the mode that this will be the standard for measuring the certain degree of hotness or degree of coldness. So talking about the temperature scales, you say is the standard mean for the measurement of temperature. So it's just the standard mean. It's actually the standard mean. A standard means or way of measuring temperature is what we call the temperature scales. So it have the numbers, it have the fixed points. We shall see on how to create it, the temperature scale. But there are 3 types of temperature scale before I go to teach you how to select it. 3 types. The first one is what we call the Fahrenheit scale. The second one is what we call the Celsius scale. And the third one is what we call the thermodynamic scale, or we call the absolute scale. So talking about this, we have the types of temperature scale. Types of temperature scale is one we call the Fahrenheit. The other thing, that's one. Number 2 is what we call the centigrade. The third is what we call the absolute or Kelvin, absolute or thermodynamics. Dynamic scale, or we can call it what we call the Kelvin scale. So its unit is Kelvin, its unit is new centigrade, and its unit is Fahrenheit. That's what we call the temperature scales. As I talk about the temperature scales, actually, the Fahrenheit has the relation with the centigrade and has the relation with the thermodynamic scale. And their relation is as shown here. Look here. So if you have here a thermometer, let's say a thermometer here. Thermometer, it have the two fixed scales, except this one, thermodynamic scale. It have only one fixed point. So, for example, one of the fixed point is what we call the ice point, which is at 0 degrees centigrade. This is the centigrade scale. The Fahrenheit scale, let's say here, the Fahrenheit scale, this is the thermometer now. The Fahrenheit scale. So let's say here, somewhere here. Let's say this is, and the other one is here. So we just have, let's say here is the ice point, which is centigrade, Fahrenheit, and Kelvin. So if this is 0 degrees centigrade, in Kelvin you just plus. So we say to get the C, it's just you plus at 0, meaning at 0 here, Kelvin is about 273. So in order to get the kelvins, you just take the degrees centigrade, you plus 273. So the formula of relation between this one and this one is you take, to get C, it's just you take plus. So you take C to get the Kelvin, scale, you just get the C plus 273 degrees centigrade. You just plus that. Okay. So as to get the Kelvin. If you have the centigrade, you just plus 273. But what does it relate with this one? If you have this centigrade and you want the relation with this, meaning the relation here between the centigrade and Fahrenheit, if you want the Fahrenheit actually, you just take 9/5, which is equal to 1.8 degrees centigrade, and then you plus times degrees centigrade, and then you plus, meaning times degrees centigrade. Hey, do you see there? It's 9/5 times what you say the degrees centigrade, then you plus 32 Fahrenheit. That's the relation between degrees centigrade and what we say the Fahrenheit scale. So this means if I want to get the 0 here for this one, I just plus 1.5. Where is my calculator? I just take 1.5, 1.8 times 0. And then plus 32. So actually the ice point is actually 32 Fahrenheit here at ice point. But how about now here 0K, for 0K here, for 0K, this means will be the negative 273, because I'll just put in 0K, 0K here, so this one will just be negative here. How about now the Fahrenheit at this point? Meaning I'll just take now, Ntachukua, what am I going to take? Is 1.8. 1.8 times who? Times degrees centigrade. What are the degrees centigrade? Negative 273. 0.80 times 273. Yes. So I minus 33. Yeah. So I'll just have here. Here. 459.40. Wow, that's okay. How about if it's 100? How about if it's 100? So if it's 100, which we call the steam point, at the steam point, meaning this one will be how many? We just plus 1.8. It will just be 2. That's about the Fahrenheit. How about this one? How about the Kelvin? We just plus 100. Will be 373 Kelvin. That's all about what we say the temperature scales. So you need to know the relation between the thermodynamic scale, the centigrade, and the absolute scale. How do they relate? Their formula of relation. You will just be asked on. That's the fourth term. How about the fifth term? What's the fifth term? Let's look on the fifth term. We're just looking here on the terms. We are on the thermometry, but the part of terms. Well, the other terms that are very important in thermometry, is what we say the thermometric material. Talking about the thermometric material, if you were asked about the thermometric material, what is the thermometric material actually? Talking about the thermometric material, these are materials whose properties varies linearly and continuously with the increase or the changes in temperature. So when the temperature increases or decreases, those materials have some properties which they varies with that changes in temperature. So those properties which vary we call the thermometric properties. But those materials we call the thermometric materials. Okay. Let's go on here to discuss about the other terms. The fourth term is about the temperature scale we have discussed it about. Let's go on to go for let's go for what we call number fifth. The fifth one is what we call the thermometric, the fixed points. The fifth term. The fixed points is just the temperature. These are the temperature. First thing is they are temperatures. Temperatures at whose a certain physical property, physical property manifests. So at that temperatures, there is a certain physical property that is being observed. For example, the ice point. At ice point, meaning liquid state starts to be the solid, while at the steam point, the other fixed point, is where the liquid turns to be the gas. And the other one is what we call the triple point. The triple point, this occurs just at 0.01 degrees centigrade. It's what we call that temperature. There is a coexistence of liquid, solid, and the gas in the same state, in the same point. So we just say, talking about the fixed points. Talking about the fixed points, we have the three fixed points here. One of the fixed points actually is what we call the ice point. Ice point. The other thing is what we call the steam point. Steam point. And the third is what we call the triple point. What about these things? What about these things, man? So when we discuss about the ice point, this is just obtained at 0 degrees centigrade. 0 degrees centigrade. 0. How about the steam point? This is just obtained at 100 degrees centigrade. How about this? How about what we call the triple point? The triple point is just obtained at 0.01 degrees centigrade. Triple point. We just say in terms of Kelvin, you know now there. We can just say here is 273.16 because the ice point actually is just being obtained at 273 practically 0.15 degrees centigrade. Is where we get the ice point. So the triple point is just obtained it at that point. Okay. This 6 Kelvin in terms of Kelvin here. In terms of Kelvin. Okay, this is in terms of Kelvin here, in terms of what we call the Kelvin. Hey, so let's go on for what we say is about for what we say about the fixed points. So talking about the fixed points, actually, the ice points, the ice point is this one at 0, and the steam point is here. While we talk about the what we say the triple point is somewhere here. Triple point. Around here, where now here at the triple point, solid, liquid, and gas coexist at the same time. And that's what we call the triple point. Triple point. Okay, let me rub here. Let me rub here. Oh, talking about the other term that we're just going to deal with, apart from the fixed points, we're just going to discuss about things like thermometric material. What are the thermometric materials? Thermometric materials. So talk about the thermometric materials. Actually, these are materials, thermometric materials. Let me say about thermometric material. Thermometric, and this is term number 6. Thermometric material. So there are 7 terms here to discuss on thermometry so that you may understand about it. And very important is thermometric material. These are just material. For example, an alcohol or a mercury within the thermometer. That is the thermometric material. Why? It's because its property, which is the length, the increasing length, it signifies the increasing temperature, or the decreasing length signifies the decreasing temperature. So talk about the thermometric material, a material whose properties varies linearly and continuously with the changes in temperature. Linearly and continuously. So make sure you, in your definition, you have linearly and continuously. If it doesn't vary, why water is not usually a thermometric material? The reason is it is not a linear expansion. It have the abnormal expansion from 0 to 4 degrees centigrade, where it's just heating from 0 to 4. We say that material should expand, actually. The density should increase, but water, the density tends to increase as it's being heated from 0 to 4 degrees centigrade. So, talk about the thermometric material, actually, is about material. First are the materials whose properties varies continuously and linearly with the temperature. So if it's not continuous or linearly, that's not the perfect thermometric material. We cannot use the questions, sample question. For example, you can just be asked, why water is not used as thermometric material? A tricky material. The reason is simple. It's because it's not linear and continuously. The reason is answers is not linearly and continuously. Simply, it gives anomalous expansion. Do you see? There we go. So talking about that, we just say about the thermometric properties. So these materials have the thermometric properties. Now, examples of this, let's say some examples about thermometric materials. Thermometric materials, for example, now it just depends on the type of, actually on the type of the thermometer that is being used. Actually on the type of thermometer that is used. Types of thermometer that is being used. Let's say about the examples. When I just speak about the examples of thermometric material. One, the example of thermometric material is about what we call alcohol. The other thing is about our mercury. For a certain type of thermometer called liquid in glass. The other thing is about like platinum wire. We use it in platinum wire resistance thermometer. So the other thing here, we just measure the resistance to get the temperature. The other thing is like material like in gas. We use it in joules thermometer, joules constant volume thermometer, which you use as the pressure to measure. We'll discuss on the types. The fourth thing we're just going to discuss, the other example is like the other material is like metals. We just say metals in the thermocouple. The other thing is about metal couples. The other thing is like examples of thermometric material is like radiations from the hot object. Radiations. So this is a vast material. Here in radiation is just study the wavelength and the frequency. So those properties, these materials which are contained with these materials, which varies continuously and linearly, are the one used as thermometric properties. So talking about the thermometric properties, thermometric, the seventh term, we call the thermometric property. Thermometric property. So talking about the thermometric property, actually, this is about what we say the actual variation now, the property which varies, the property of thermometric material that varies continuously and linearly with the temperature. So the same thing, it should be linearly and continuously. So this first is the property. Here is the property of thermometric material, which varies. Hey, know this, continuously and linearly with the temperature. That's what we call the thermometric property. Those about the terms is sasa, we say you know about the thermometry. Even if now we're just going to start about the types now, you know about the thermometry. Let's go on for the types of thermometer. Before we move, I said this thermometry has the two things, the terms and what we call the types, but you need to know about the measurements. So we're just going to learn about the measurements. Measurement of it. Before studying the types, each type is used to measure the temperature. So let's discuss about actually the measurements. What are the measurements? How do we measure temperature using the thermometers? How do we measure temperature using thermometers? How do we measure temperature using thermometers? How do we measure temperature using thermometers? So we say in the measurement of temperature, we say the temperature is not proportional to thermometric properties that is being displayed. For example, example of thermometric property, I haven't given you the examples. It's like the length within the liquid, the length of the liquid that changes or that increases as the temperature increases. Or in gas, we say it's either the pressure or the volume, depending on the type of gas thermometer. So because there are two types of gas thermometer, with which is being used at the constant pressure or at the constant volume. So if we say at the constant volume or the constant pressure, we just say so let's see here. Let's see here. So when I talk about let me say about the properties now. Let me say about the measurements. Actually, the measurement of temperature is just based on the principle that the volume, the thermometric property, is direct proportional to what we say. Thermometric property is direct proportional to what we say the changes in temperature. So talking about this, we just say if you have a certain property X, this will just be direct proportional to the change in temperature. Fit. So if, for example, I have at temperature at 0 degrees centigrade, I have a certain property X 0. At 100 degrees centigrade, I had a property at 100. If I say that the temperature which is I don't know it's just theta, I'll just have that property theta. So the property, the temperature being the subscript in the letter that signifies the property. It can be the pressure, it can be the length, it can be the volume, it can be the resistance, it can be the EMF, depending on what is being measured. It can be the height. So the difference between the temperatures, the change Change in thermometric property is that proportional to the temperature. And you know, for example, if this is my liquid glass thermometer, if it increases the length, that means the temperature has increased. So this means, yeah, if I change the property, also if I change the temperature, I change also the property. So this means if I have to take 100 minus 0, this is just equal to K, because if I have the change in property, it's just equal to K, meaning they are direct proportional, so to change of temperature. So if I have 100 minus 0, this means I'll just have the constant, but I have 100 new centigrade minus 0 new centigrade. So this, let me take this as equation 1. How about if I take this minus this? So if I have a physical property at 100 minus that at theta, it's just equal to K, but I have what? 100 minus 0 new centigrade. So if the changes in temperature signifies the changes in the physical property. So for example, if I take, let me say, now the temperature changes from here to 0, now theta minus 0, it's just equal to K and theta minus 0 new centigrade. That's equation number 3. So it depends on the changes that you want. If you want to find a certain unknown unknown temperature, you just take this for unknown temperature with 0 and 100 for that 0. You make the comparison, you divide the two equations, dividing the equation 1 and the equation 2 here. For example, I can just take equation 1 and equation 2, I divide. So I take equation 1 divided by equation 2 here. What am I going to get? I just get, I mean equation 3 dividing by the equation 1 here. So what am I going to get? I just get x of theta minus x at 0 over what we say x at 100 minus x at 0. It's just equal to what we say is 100 over what we say, meaning k and k cancels, so we just have theta. So getting the theta now, here, when we say about this, we take equation 1. This is now the first equation here, which is 100 over what we say the k, we say 100 minus 0 is just 100 over k, who is this? This is theta. Theta minus 0 is just theta. So k and k cancels and we remain with the theta equal to what we say 100 x theta minus x0 over x 100 minus x0 times what we say 100 times 100. And that is the general equation for finding the temperature at any point. At any point. So if you are looking to find the temperature at a point, we measure it like that. We measure using the temperature, the general formula as that. This is the formula for measurement of temperature at any point. This one. So you can measure temperature at any point using that formula. By comparison with 0, with 100, the steam point and the ice point. So that formula can just be used for different physical properties. For example, we can just use it. Finding theta is just at if my x is just equal to p, pressure. So I just use here pressure at what? At theta minus pressure at 0 new centigrade over pressure at 100 minus pressure at 0 times what we say is 100 new centigrade. So that is all about. You get the temperature in new centigrade. Hey, that's about just the introduction, the terms. Dang, we are done. If it's about the resistance, you just put the resistance. If it's about the resistance, theta, if R, it's just about the resistance. So you finding the theta is just equal to resistance at that temperature minus resistance at 0 over resistance of 100 minus resistance at 0 times what we say 100. That's all about the temperature. That's all about the temperature. That's how we find the temperature. If you don't have my books, make sure you have my books, so as you may understand it step by step, step by step. So DM those numbers down once you get my books. Very competent books. Let's go for the types. Types of thermometer. Types of thermometer. Types of thermometer. Let's go for the types of thermometer. How about the types, man? Talk about the types actually. Types, we have the 5 parts, 5 types of thermometer. We have actually many, but for your syllabus, you need to start about the 5. So we're just going to start about the first thing is about types. We have the 5 types. 5. 1 is about what we say liquid in glass. Thermometer. The second thing is about what we say, meaning there is a liquid fluid within the thermometer. Gas. Which has the 2 types actually. 1 is about the constant pressure or the constant volume. Pressure. That's all about. So at constant pressure, we measure the volume. At constant volume, we measure the pressure. So at our formula, we just substitute the pressure theta minus pressure 0. So talk about the third thing is about what we say, and that's about the liquid. This is about the gas. We have the platinum wire resistance. Thermometer. The fourth one is actually about the thermocouple. Thermocouple. We say thermocouple. And the fifth one is about the pyrometer. This uses radiations. Pyrometer. Thermocouple uses the EMF. So here, for example, let me make you useful those concepts in thermometry here in terms. Liquid in glass thermometer uses what? The liquid. Liquid is the material, while the property is the length. So in measuring, you just say theta is just equal to length of theta minus length at 0 over length at 100 minus length at 0 times 100. That's you say about. So here about the pressure, actually, we talk about the volume at the constant pressure. While here we say about the constant volume, so we measure the pressure. While here, what's the proper? The material is the gas, thermometric material. While the property are those ones. So what is the material here? The platinum wire is the material. While the resistance now is the property. Resistance is the property here. Resistance is the property. When we talk about the thermocouple, we measure the metals. Metals, series of metals we call the Seidbach series. Here, metals. Those metals are the material, while there are differences in strength, which is that the difference in strength, which is just the EMF to be generated, is what we call the thermometric property. So the EMF is the thermometric property, while the metals, they are thermometric material. So we have the what we say is about the EMF. This is the property. How about the pyrometer? Pyrometer is about the radiations. Radiations are the material, while the property is the wavelength and the frequency. So the wavelength and the frequency. frequency of those radiations are the one that we use to measure the temperature as the thermometric property. Dang! So talk about that. That's good. Super. So let's go to discuss about the liquid and gas thermometer. Each one and why. Which one and associated questions. Each one and associated concepts. That's all about. What's the time? Let's go on. Okay, the time still allows me. Let's go for the liquid in gas thermometer. Yeah, let me go for liquid in gas thermometer. What's the time there? What's the time, Chief? Okay, so we're just going for the types as normal. So let's discuss about the types now. Types of thermometer. So talking about the types of thermometers, we have the liquid in gas thermometer. Talking about the liquid in glass thermometers, this is just the type of thermometer in whose the liquid is just filled in and the length changes according to the increase in temperature or the decrease in temperature. So the changes in temperature changes in length. They are direct proportion. So in measurement, I've just said this can be of two types. It can just be either alcohol or can be just what we say. Can just be alcohol or can just be a liquid in glassy thermometer. So talking about actually talking about this, we've just said about the liquid in glass thermometer. Number one is liquid in glass thermometer. So talking about the liquid in glass thermometer here, this one it can be either alcohol or it can be what we say the mercury. So talking about the alcohol or mercury and alcohol, they can ask you something like the comparisons between these comparisons. They also can ask you about what we say. So on comparison or comparing, this one is mostly used. This one is mostly used. Why? They can ask you why mercury in a glass thermometer can just be used. So liquid in glass thermometer is just the thermometer here, but filled with a certain liquid. Its structures like that. It have a bulb. It have the stem. Whose the stem has the core. The core in which now mercury is being filled. Mercury is being filled here. Now it rises over the length. So here, the length is the physical property. So we just say, talking about this, the mercury, actually talking about now the mercury. Mercury is the conductor. So it have the larger conductivity. But talking about the alcohol has the low conductivity. So low conductivity. So talking about the alcohol also, it's colorless. While this one is colored, silver colored. It's like a silver. It's like a gray, like my shirt. So it's observable when it starts to rise. While here it's colorless. So you just see it like a red. That's a dye. We just mix with the dye, so as we may see, we will observe it. So that increased the cost for the operation because we need to buy the dye, man. So colorless. The other why this is being used actually, this one has the low what we call the heat capacity. So giving it sensitivity. So this one is very sensitive. Why? What's the heat capacity? Talking about the heat capacity, actually, heat capacity is about the heat required just to rise the 1 centigrade. Specific heat capacity. So if you require a very, very small heat to rise a 1K, that means this is more detective to the temperature. So this one is more favored than this one, which have high compared to this one. High compared to that one. Also, this one, specific heat capacity. The fourth thing, the difference is actually the alcohol can wet the glass due to the presence of water, so it's more adhesive. While this one is more cohesive. So this one is cohesive. while this one is adhesive. It wets the glass. While this one, cohesive, doesn't wet the glass. Yeah, that's all about the cohesive. So this one is, why is it being preferred? It's a conductor. The second thing is, doesn't wet the glass because more cohesive. So it just rises without a resistance upward. And the fourth thing is more sensitive. And also it's colored. So when it just rises, it's increase in length. It's just observed easily. That's why we prefer this. So liquid in glass thermometer, you know about this. You need to know about the structure. So the things here you need to know about the structure. That's one, the stem, the core, and the bulb. The bulb holds the mercury. And you detect the temperature using this stem. Here is where the stem absorbs heat through the glass and the mercury starts to expand and its length increases as it starts to rise. As you observe the changes in length, that's how the temperature changes, okay? So here, liquid, you need to know about the advantages and disadvantages. Advantages. Actually, liquid in glass thermometer, it's simple and portable. It's direct reading. You just read direct from the source here. You just put in contact with the source, and you measure it direct through observation. Also, it's simple. You can hold it. It's cheap also. It's like 25k Tanzania shillings. So it's cheap. Those are the advantages. What are the disadvantages actually? Disadvantages. The glass also tends to expand, because actually there is a question they tend to ask mostly frequently. They ask thermometers tend to measure their own temperatures, their own temperature, not the temperature of the object to be measured. Why? Explain. So you say they need to absorb the temperature from the body that they want to measure first, so as they may get that temperature to attain the thermal equilibrium to measure that temperature of that body. So the thermometer doesn't measure the temperature without attaining the thermal equilibrium. So when the thermal equilibrium is reached, is where now we say you can say that thermometers tends. Why thermometers? We explain. Thermometers tend to measure their own temperatures. It's because they need to absorb heat from the hot object, so as they may have the same temperature, which we call the state we call the thermal equilibrium, so as to display the temperature of the hot object. So one of the disadvantages actually, the glass and the mercury is not that the temperature will be measured, so there is an absorption of energy. So there is a loss of heat from that object. So the temperature that you're measuring has a loss, because the mercury and the glass has to absorb that energy, so that object has lost its energy. So the temperature that you're obtaining by measuring using the liquid in glass thermometer is not the perfect temperature. It has some deviation below the hot object temperature. So we say the glass and mercury is not at the temperature to be measured. Also, it have the small range, very small range. It's just for example, that which you are just mostly using in your schools is from 0 to 100. So very small range. How do you measure the core of the earth? About 500 centigrades. How do you measure some temperatures above 100? So it's very small range. Also, we just say actually it can't measure the rapidly changing temperatures. So if you measure this, my hand is about 500 new centigrade, and it rises, then you shift it to 0 new centigrade. It can't change just abruptly. It cannot fall down and rise abruptly. No, it doesn't measure the rapidly changing temperatures. doesn't measure rapidly changing temperatures. Yes, that's all about what we say, the liquid in the glass thermometer. How about now, let's say, how about here? Okay, those are disadvantage of liquid in the glass thermometer. Also, you know, one of the disadvantages actually, alcohol is not preferred than mercury. It's because alcohol contains some percentage of water. So if it contains some percentage of water, meaning there is some deviation in measurements. There is abnormal measurement. The scale wants to be linear from 0 to 4 units centimeter than mercury. So mercury is more accurate than the alcohol. That's how we prefer the mercury also. That's about it. Let's discuss about the second type. The second type is about the gas thermometer. How about the gas thermometer? What is it? The gas thermometer. So talk about the gas thermometer. This depends. Either it is the gas with a constant volume, if we measure using the constant volume thermometer or the constant pressure thermometer. So if we measure the constant pressure thermometer, this means that we measure the volume. If we measure the constant volume thermometer, that means we measure the pressure. So we just say, oh, can you joke like that? Let's say here, now I'm measuring the gas thermometer. If I measure the gas thermometer, this can be joules. Joules constant volume thermometer. Why this is constant pressure. So if I measure using the constant volume, this means I'm measuring what? Pressure. So if I'm measuring pressure, meaning the P will be theta minus P at 0 over P at 100 minus P at 0 times what we call 100. That's all about, man. That's all about. How about the constant pressure? Let's talk about the constant pressure. This will just be, meaning we measure the volume. At constant pressure, we measure the volume. So what varies here is the volume. So volume at theta minus volume at 0 over volume at 100 minus volume at 0, but times what we say 100. That's all about it. That's all about it at constant. That's all about the gas thermometer. But I will magnify this, the joules constant volume, its structure, mode of action, and advantages and disadvantages. So let me discuss about this, the joules. Let me magnify it. So talking about the joules, the thermometer, its structure now. So here, structure and mode of action. Structure and mode of action. Actually, let me talk about here, structure, mode of action, advantages, and disadvantages. So let's discuss about the gas thermometer. So talking about the gas thermometer, the structure, we just say this is the bulb. So if this is the bulb here, it has a certain stem here. So we can just say here, yeah. So here it's just filled with mercury to a certain point here. Let's say the point where it reaches 0. Yeah, but when it's just it's just pressed to a certain hot liquid here. Yeah, this is mercury inside here, mercury inside here. So originally when it's at X, the mercury Q upper, this means the mercury is in here. So we measure this height from here to here as it moves, because when pressed in a hot, yeah, this is the hot liquid, hot liquid. So here is the hot liquid to be measured here, hot liquid to be measured here, hot liquid to be measured here. So when it's just pressed the bulb, this is called the bulb. Yeah? This is called the bulb. Yeah? So here, this is the mercury. So this is the point, original point. So when pressed in a hot liquid, the gas, the mode of action now, the mode of action, the structure is this one. So the mode of action is when placed in a hot liquid, the gas inside the bulb starts to gain the heat and expands. As it expands, it pushes down the mercury from the original point to a certain point of heat, which equals to the pressure that has been exerted due to the gain of kinetic energy of the gases here from the bulb. So the heat is being recorded as in millimeters of mercury that has been dispersed. Now the millimeters of mercury are the pressure caused by the temperature of that hot object. So you get it, man. The temperature is being measured as the pressure theta minus pressure at 0 over pressure at 100 minus pressure at 0 but times 100. How do you get that pressure? Pressure is this H. H are the millimeters of mercury dispersed. Millimeters of mercury dispersed. That's about the joules. So it's just being measured depending on that. Let's discuss about the advantages now. Advantages and disadvantages. Advantages and disadvantages. Before I don't forget this, gas type of thermometer is the standard thermometer that is being used. So among the 5 types, gas thermometer is the standard one. Yeah, so gas thermometer is the standard one. Gas thermometer is the standard one. Let's discuss here. Let's go for it. Okay, let's go for advantages. How about the advantages of gas thermometer? 1. Actually, it's more accurate. The second one is more accurate and it's taken as the standard. Hey, not this. This is taken as a standard. To all types of thermometers. And actually, let me tell you, why is it more accurate? It's more accurate because of its expansivity. The expansivity for mercury or alcohol is less than for the gas, because gas have very weak intermolecular forces. So whenever there is a very small temperature, can cause the larger kinetic energy within its molecules, which cause their spreading. So the expansion here is very easy because of low coefficient of expansivity. That's about the accuracy. How about the other thing we say? Another thing is that we say, actually talking about the gas thermometer, it have a very large range. It's not like in liquid in gas thermometer. So this have very large range, meaning the ice point to steam point. Very negative temperatures to those high temperature above. The range there from the smallest smallest point to the highest point. The range, smallest value to be measured to the highest value to be measured. Very large range. The third thing about the gas thermometer actually it's actually, we say it can just measure linearly and continuously. So when you apply when the temperature changes, also its property is either volume or pressure changes also linearly. So it's also linearly and continuously. Hey, let's shift about that. So let's talk about things like disadvantages. Disadvantages. So talk about the disadvantages for gas, we just say very large than that of the liquid in glass. So very large. Very large. The second thing, actually, so it's not portable. It's not portable. It's not direct. You cannot measure it direct. You need to calculate it. It's not like liquid in glass thermometer. You could just see it. This is not direct measurement. And the fourth thing, the gas to be measured, it's not the temperature to be measured. It just measures very small quantity. It can't measure the very small quantity of substances, because that bulb, the bulb is very large, so it can't measure the bulb. This bulb is very large, so it can't measure, doesn't measure, doesn't measure small quantities of liquids. So it just measures those large amounts. Also, we say, chief, we also say the liquid in gas thermometer, we just say its size is very large. I've just spoken about it. Yeah, I've just spoken about it. Okay, so let's talk about the third type. The third type we say is about the platinum wire resistance. Platinum wire resistance. Let's say about the platinum wire resistance. So talking about the platinum wire resistance, thermometer. Actually, platinum wire resistance thermometer, this is another type of thermometer that uses the platinum wire as the thermometric material and uses resistance as the thermometric property. So in measuring the temperature, actually, the temperature is just being measured using the resistance. So X is just equal to resistance. So you just say resistance at theta minus resistance at 0 over resistance of 100 minus resistance at 0 times 100 is what we measure the temperature. That's all about. So this one uses the resistance. It takes the resistance, platinum wire resistance, and it puts it, the mode of action, We just take the platinum wire and set it into the Wheatstone bridge. You started it in current. Yeah, if you are in Form 3, I think you started about the Wheatstone bridge. So we take this platinum wire resistance, we put it into a bridge. A bridge is like this. So you need a bridge in order to use this thermometer. So this is electricity here. We have the thermometer. And actually in the bridge, you know, we have the fixed and we have the variable. So this is the platinum wire here. Come and see here. So these two are fixed values thermometer. Actually, their values are known fixed. Why this one is known but is variable? So you vary it and you know it. Known variable. So you vary it as you vary it so as to get 0 here. You get the 0 in the galvanometer. It's a null diffraction method, G. So G, you get when you get 0, meaning this resistance is just equal to this. So you balance it until you get the 0 in the galvanometer. That's where this resistance has balanced with this. While the object is the hot object is just pressed in contact with that platinum resistance wire. So as it is in contact with the hot object, it generates the resistance. Now you measure the resistance, which now you just use it to calculate the temperature. So the mode of action is that the wire is being pressed on the one arm of the Wheatstone bridge, and you vary the resistance of the other variable arm so as the galvanometer reads at 0, at 0. So when it reaches 0, this means this branch has balanced with this branch in terms of voltages. That's where we say if the current is this one, comes here, divides at this junction, current 1, and this is current 2. So we say, oh, if this is X, this is Y, and this is platinum wire P, and this is K. So this is K. So we just say if these are resistances, we can say the voltage across this and this are parallel. So I can say I1X is just equal to I2Y because they are parallel. So the voltage will just be the same. So if they are parallel, the other thing is I divide by this one is I1P. It's just equal to who? This is I2 who? K. So I cancel. So I just have this K. This one is unknown. Unknown. This is what we say the unknown. Platinum hot object. So the hot object will just generate a certain P. So we need to find the P will just be equal to X K over Y. That's what we say. We say resistance. So if you get this resistance P, you come and put it here, and then you find the temperature using that relation. There we go, and that's the mode of action. It's just used in the Wheatstone bridge. If you forgot about that, don't forget about this. It's just used from the Wheatstone bridge. Hey, let's move on. From there now, I can just say about the platinum wire advantages and disadvantages. Now you know about it. Let's discuss about advantages and the disadvantages. Advantages and the disadvantages. Advantages and the disadvantages. Let's talk about advantages and disadvantages. Advantages and disadvantages. Let's talk about actually advantages of platinum wire. The third advantages. Advantages here about the platinum wire is have a very wide range than even the gas. So wide range. Also, it's more accurate than the liquid gas, but not more than the gas. Yeah. And also, we just say its range actually is very large. We say its size is not larger as that of the gas. So very small size, not compared to gas. Gas one is very large, so it can just measure some temperature. But disadvantages. Actually, this platinum wire resistance, it have the self-heating mechanism. It just find it automatically to heat itself. So if the temperature increases itself, this means there is a deviation in temperature. We measure the hot object that is required to measure required to generate its temperature, its resistance, so as we may measure its temperature. But if our thermometer also generates its own temperature, that means we just read the incorrect results from the hot object. So it have the self-heating mechanism, which results to some deviation. Also, platinum wire resistance tends to have some properties like we say, oh, I've just remembered. Why platinum wire? There is a question, why? Sample question. Why platinum wire? Why platinum wire? Why not a copper wire? Why not nickel wire? Why? So we say actually a platinum wire, it has the two unique properties. The first property that is very unique, one, is the high melting point. So if it have a high melting point, guess what? Even at high temperature, still it can be measured, because the platinum wire doesn't melt at that temperature. But if it could have very small melting point or very low melting point, it would just melt at very small temperature. So we would have a small range for the measurement. The second thing is because of low coefficient, temperature coefficient of resistance. I mean high temperature coefficient of resistance. What is actually the temperature coefficient of resistance? Temperature coefficient of resistance is actually the fractional increase in resistance per degrees rise in temperature. So when you just rise the temperature for 1K, how much resistance increases? So if you have a fractional increase, very large fractional increase when you just change a small temperature, this means the fractional increase, the coefficient of friction is very large. So when you just rise a small temperature, you observe the large resistance. This means it's more sensitive. So it have a high temperature coefficient of resistance, which makes it more sensitive, chief, meaning giving the high resistance even at very low temperature. That's why we use the platinum wire. That's about the advantages and the disadvantages of what we call the platinum wire. Yeah, let's go on. And it's not direct measurement. The other disadvantage is indirectly measured. So you need to calculate, you need to know how to install it from the bridge and what and so on. So let's go on for number 4. Number 4 is what we say about the thermocouple. 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 Let's discuss about the thermocouple. Thermocouple. Let's discuss about the thermocouple. Let's discuss about the thermocouple. Thermocouple, this is number 4. It's a type of thermometer that actually uses the concept we call the thermoelectric concept, or we call it a Seebeck effect. What is Seebeck effect actually? Seebeck effect is just the phenomenon of development of EMF due to differences in temperatures between the 2 points. So if you have the 2 points here with different temperatures, there is the EMF developing across them. So we say, talking about the thermocouple, it's just the type of thermometer that develops EMF due to difference in temperature. So actually the thermocouple, it's have a certain voltmeter here, and it's have a cold junction and a hot junction, which have been linked here. Look here, Chief. Yeah, so we have the hot junction and we have the cold junction. So what is about the cold junction? This is about 0 degrees centigrade. It's just maintained at 0 degrees centigrade. While this is where the temperature to be measured in. So the substance that is to be measured comes in contact with the hot junction. That's the structure for the thermocouple. So it just develops the EMF whenever there is a difference. So this one is just maintained at 0 degrees centigrade, and this one measures the temperature of the hot object. So this one works under the principle we call the Seebeck effect. Seebeck effect. The principle called the Seebeck effect or Seebeck phenomenon. What are the Seebeck phenomena if they say to define? Terms. You need to know about these terms. Yeah? Terms used here. Terms. What is Seebeck effect? The term number 1 is the Seebeck effect. It's the phenomenon. What is the Seebeck effect? Phenomenon, first thing, of development of EMF. Due to difference in temperature. So if there is a difference between the 2 points, there is EMF development. So if the EMF has been developed between the 2 points, you can now calculate the temperature. Now is about the E at theta minus E at 0. You measured E at 100 minus E at 0 times what we call 100. Times what we call 100. That's what we measure the theta. Hey, dang, that's good. That's about the thermocouple. What about before I just move on, Seebeck, why Seebeck? There is somebody, we recognize him, very good man, worked some days and nights to discover the series of metals. Go and look to my book there. There are a series of metals that are called Seebeck series. Seebeck series is a series of metals that whenever you pick up the 2 metals and put them in the thermocouple, the 2 ends of the thermocouple, you generate the EMF. And the EMF will depend on the type of the metals. If the 2 metals are much differ in the series, if you take the first one and the last one, you develop the greatest EMF. But if you take that one with the one, so you look to the difference. If the difference between the positions is very large, the EMF will also be large. The EMF developed, and so also the temperature that is being measured. Okay, so talk about the Seebeck effect is about that. How about the property now? What is the relation between the EMF now and temperature? The relationship between the EMF and temperature in the thermocouple. Yeah. the EMF, relationship between EMF and temperature. EMF and temperature. Okay, let's discuss here. Let's discuss here about the relationship between EMF. Relationship between EMF and the temperature to be measured. So the EMF to be measured is just equal to A, but theta is the temperature, plus B theta square. That's the relation between EMF and the temperature. So talking about the A and the B, these are just constants of metals. Usually. Talk about theta, this is just the temperatures measured, and E is the EMF, electromotive force. That's all about what we say. What do we say about that? There we go. So what's about the thermocouple, man? So talking about the thermocouple now, we say the relation between EMF here, graph showing the EMF and the temperature. You see, it's like this. So this is the maximum EMF, maximum. So it just goes and lies to a maximum point, and then it starts to invert. So chief, this temperature is what we call the cold point, cold junction, cold junction. While this temperature here at maximum EMF, we call it the neutral temperature, QN, the neutral temperature, chief. While the fourth one here, the inverted, we call the inversion temperature. Inversion temperature. You see, QI. That's all about. So talking about that, let's go on for something we call thermocouple. Let's differentiate this. Let's find the cold, the neutral, and the inversion temperature. Will be asked, chief. So talking about the cold, is that temperature of the cold junction, which is now maintained at 0. So this should be kept constant, and that is one of the disadvantages. So you need to find the mechanism to maintain it, even if the other end is being changed. The second thing is about the neutral temperature. So the neutral temperature is actually the temperature of the hot junction when the cold junction is maintained at 0 and the EMF has reached its maximum. So talking about the neutral temperature is the temperature of the hot junction. And the neutral temperature is the temperature of the hot junction actually when the EMF is maximum. So the other term here is about the neutral temperature. What's the neutral temperature, man? Is the temperature of the hot junction when EMF is just the maximum. Do you see? But talking about the second term is about the we say the inversion temperature. Inversion temperature. And this we can just obtain it the neutral temperature QN. So when E is max, we mean, for example, here from our equation, check here, we say E is just equal to A theta plus B by theta. So for neutral temperature at this point, this one is maximum. So let's differentiate, for example, this with respect to temperature. So if we differentiate the EMF with respect to temperature, this means this will be minus 1, this means will be minus 1 plus 1 plus 1 to this side times 1. So this will just be A. While this one will be, this is square, so will just be theta. You see here, So if you differentiate at maximum, since it's maximum, dE over d theta will just be equal to 0 since it's maximum value. So when you differentiate what is constant, because the maximum is constant, we just get 0. So this one is just equal to 0. So 0 will just be equal to a plus b theta. So this means what is now theta? Theta is neutral if this is 0. So at this one, at dE over d theta being equal to 0, now theta will just be equal to Cn, the neutral. So we say this is neutral. So talking about the neutral will just be equal to A over B, but negative. Do you see? So this comes to this side and you divide by. That is the neutral temperature. That's how to get the neutral temperature. You just differentiate the value and that will be 0. Let's go on. Let's go for the other thing is about, let's say about inversion temperature. How about the inversion temperature? Let me say about the inversion temperature. The second term, the inversion temperature. Inversion temperature. Now you know the neutral temperature. How do we get the neutral temperature actually? The neutral temperature, negative A over B. How about that? The inversion temperature. So talk about the inversion temperature. This is actually the temperature of the hot junction. So it's the temperature of the hot junction when cold junction is just kept at 0 and the EMF has reversed to minimum, to 0. Do you see? So talk about this theta condition now. Theta to be equal to inversion if EMF reversed to 0. You see? So we just say now, getting that, we can say QI mathematical value now for QI value is theta I minus theta N, which is just equal to theta N minus theta Q. This one. So talking about this will just be 2 here, T. I minus this one will be plus the cold over 2 is just equal to what? The Qn. That's all about now. So when I'm just talking about the neutral temperature now, and the cold is maintained at 0, so this means this is 0. So it will just be Qi over 2 will just be equal to neutral temperature. That's why we say the neutral temperature, yes, that's why we say, wait. Yes. Yeah. So when we say the neutral temperature, actually, what do we need? We need the inversion temperature here. So what we need here is the inversion temperature, not the neutral temperature. We need this. So when it just goes to this side, it just becomes. Let's go here. We need the inversion. We're talking about the inversion, not that one, not the neutral temperature. We can just say now, okay. What's about this? This is inversion. It's just equal to 2 Qn minus Q cold. That's all about. Also, you can just get this by using differentiation equation from there, but also the other way to get it, we just say, okay, we said from our equation E A plus B theta square. If this is an inversion, meaning this is 0, so this is 0, it's just equal to A plus A theta plus who? B theta square. That's the relation at E is just equal to 0. So this temperature, if this is 0, this temperature as inversion, they are QI. So this comes to this side. If this comes to this side, this means here. Let me use the other marker pen here. So coming to this side, so this one, it just comes to this side, showing negative A over what you say B is just equal now to Q inverted. That's what we say over what we say the 2. But we said, what did we say? We said that Qn, what's Qn? Qn is just equal to A over B, 2. But we said here, let's look here. We said, when you differentiate this one, actually, we said for neutral, let me remind you, for neutral, we said E is just equal to A theta plus B theta squared. So when you differentiate this with respect to D theta, is just equal to A, but what is this? This is theta, so it's minus, will just be 0 plus, who is this? If you minus is 2B. So talking about this one is just equal to 0 if theta is just equal to neutral, if what the E over the theta is just equal to 0. So we just say negative A over 2B is just equal to what we say the neutral. So this and this, we can say now P of inversion is just equal to this one is the theta. So this one is what we call theta. If that is theta, this means this negative, this one is Qi. So it's Qi over who? Over 2 is just equal to Q neutral. That's the relation between the inversion temperature and the what we call the neutral temperature. That's how we relate them. The last thing is about apart from thermocouple, we can say about the pyrometer. What's about the pyrometer? Pyrometer actually is just the type of thermometer that uses the radiations. One of the we haven't discussed about advantages. Advantages, let's do them first. Advantages of thermocouple. Actually, we say thermocouple, thermocouple now. One of the advantages is more accurate than that one, and also it's more in size. Also it's have the wide range. It's these points are just like prostitute. They just fit to different points. So you make sure you just know actually the thermometer. Things like that. But also a special advantage of thermocouple, it measures the varying. Measures the varying. Measures number 4, measures rapidly varying temperatures. That's a very special advantage of thermocouple. The other thing, the disadvantages. Disadvantages actually, a thermocouple disadvantages here. Disadvantages. Thermocouple actually is more complex. Very complex in measurement. And actually, here one of the disadvantages is about the range. I've spoken about the range actually. One of the disadvantages within the thermocouple is actually, we say it have the self-heating mechanism. Self-heating mechanism. Now it's indirect measurement. So the self-heating mechanism devices there too. there is a self-heating mechanism problem in the thermocouple and the platinum wire resistances. These points are just the alternatively used. Yeah? So you just know which type and what are you discussing about. Yeah? The last one is about the pyrometer. This pyrometer measures the temperature by using the radiations properties. So either the frequency or the wavelength of the radiations. Let's see it. Let's discuss about the pyrometer. 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 What is pyrometer and how does it operate? Pyrometer. Pyrometer. Let's talk about the pyrometer. So talk about the pyrometers. Pyrometers, this uses radiations. To measure from the hot object. So if this is the hot object, let you see. This can have the two types. It have one, we say the total types. These are the types. Yeah, we have the total radiation. And we have the optical pyrometer. So we have the optical pyrometer and we have the total radiation pyrometer. Talk about the total radiation pyrometer. This measures this one actually. This one measures all radiations, all. While this one measures only visible radiations and colors. But both use the proper thermometric property, which is the radiation of the frequencies. So we'll discuss about this optical. How do we use it? Actually, this one is more accurate than this one. So this one have the wide range. So this one have the wide range. Why? Because it can measure infrared radiations, which is below, which are being refracted below the red, and violent, ultraviolet, which are being refracted than violet. So this only measures that visible spectrum. So to ultra, it measures those radiations. We'll talk about radiations in heat transfer. In heat transfer. That's all about. Let's discuss about its structure and mode of action. Actually, the pyrometer, if this is the object to be measured, hot object, it just emits the radiations. Every object emits radiations. And so there is a certain lens here. So the lens just corrects those radiations and then passes through, we call a lamp. Now the lamp is the one connected to the circuit of electricity. So we have the variable resistor that we vary it so as to be seen here to the other lens here, the other lens here. So there is a certain observer here, certain observer. Here is the observer viewing the radiations from this lens and are being filtered by a certain ready filter. So there is a certain mirror to filter out just the radiations, and the lens just to magnify the images. So here, let's say the ammeter, and this is the source for current. What is done here? Mode of action now. The mode of action. This is the structure. This is the mode of action. So what is being done here is actually the variable resistor is being varied such that the radiations from the hot objects tend to come in phase with that radiations from the lamp. This is what we call the electric lamp. and this one is the observer. So the observer observes if that is the object that I'm measuring. So I take my lamp here and my lenses, which are in series. So I just put them here, directly to the line joining the object, and so this variable resistor is varied until the lamp which emits the electrical lamp, which emits now the radiations from this source, the EMF, such that these lamp radiations have the same radiations as that object. How do I know have the same radiations? Is when I don't see it exactly, that object, the radiations from that object. But when I just use those lenses, I can just see the radiations. It's like there are two objects. But when I see just like the same objects, this means the radiations from my lamp, the electrical lamp, has been the same to that from the object. So this has no involvement of the contact to the object, but this involves the optical now, pyrometer. You val, so the mode of action, the lamp is varied its intensity of light until it's corresponding to the object to be measured, the radiation coming from the object to be measured. That's the mode of action. And so the advantages and disadvantages, actually, there in my book, I've just explained it. Make sure you find out my books in WhatsApp. So we just say about, let's talk about that's about the mode of action. Advantages. Let's talk about the advantages, actually. Advantages now of the pyrometer is, first thing, it's no other the contact. No physical contact with the body to be measured. The second thing, that's an advantage, because you can't measure by putting a thermometer into the most hot furnace, for example, of iron, for extraction for iron. That will be a mechanism to kill, just to destroy that thermometer. But if it's not in contact, for example, how do you measure the temperature within the cup there? It's by pyrometer. So you just measure the radiations coming out from the center of this. That's about the advantage. No physical contact. That's an advantage. The other thing, actually, about the thermocouple, it's more accurate. The other thing about thermocouple, very different, is that thermocouple has a wide range. It measures temperature above 1.5 hundredths. So it's wide range of measurement. That's all about. Also, it have the small size. It can have a small size. Disadvantage is costful. And this is one of the disadvantages also in platinum wire resistance, because you use some instruments that you add, like bridges. So it's more costful also. Costful. Disadvantages. Most costful. You see, it's indirect methoding. You see, things like it can measure the rapidly changing temperatures. You see, yeah, that's all about. But there are some things here you need to know. Actual thermometer measures the temperature of itself. It's not of the object to be measured. Hey, See you. Let's meet to the solving session every holiday at Ubungo Perfect Vision. See you. DM, follow out my WhatsApp, subscribe, and get my books for solving. Physics is skill. A skill you can learn by hearing or just by reading. It's by practicing. You twist out your brain to start. See you. Let's go on for the session number 2, which is heat transfer.